I welcome you all in this course of Introduction to Heat Transfer, a practical oriented approach. And today is lecture number 12, and in this lecture we are going to see the surface radiation exchange and how it is relevant in the mode of heat transfer, which is radiation heat transfer. So I am Amraraj Sawant, Assistant Professor, Department of Mechanical Engineering. So just before starting this lecture, I will point out some ideas about heat transfer, modes of heat transfer. First is a conduction, and conduction is mainly happening within the solid. Second is a convection, and which is a combination of convection and advection, which is mainly happens due to the flow of fluids. The fluid means gases and liquids, and in radiation the heat transfer will occur due to the electromagnetic waves. And to be specific, in radiation heat transfer, the electromagnetic waves in which the charges on atoms and molecule will oscillate with their central position, and with this oscillation they transfer the energy from one side to another side with the speed of light. So that's why the radiation is the most prominent and effective way to transfer the heat within short time. So introduction, the heat transfer by electromagnetic radiation between this surface, okay, is called as a radiation. So it doesn't require medium, as we have seen this in before lectures. So it is important for furnace, spacecraft, oven and insulated cavities, and for designing of these applications, and to design how the heat transfer to be takes place in the case of radiation, and how much we need the heat transfer in these cases, and to control this heat transfer, that also we can see this in radiation. So net exchange with a surrounding. What is the title here? Net exchange with a surrounding. So what is mean by that? Let's take an example of this metal plate. If let's say this metal plate is radiating heat energy, let's say 50 watt to the surrounding, then this metal plate is having certain temperature, okay, and surrounding is having certain temperature. Then because of difference in the temperature, there is heat is going to be transferred. But in first case, the metal plate which is transferring the heat, okay, in the radiation heat transfer mode, so this metal plate to the surrounding, there must be some exchange of heat transfer, and that we are going to mathematically formulate and analyze in this slide. So for surface at T1, okay, the surface temperature, let's say it's T1, radiating to the enclosure at T2, means surrounding temperature, if it is T2, then total heat energy or heat transfer due to radiation of this metal plate to the surrounding is sigma into area, which is surface area of this metal plate, and T1 raised to 4 minus T2 raised to 4, where T1 is the surface temperature of this metal piece which is radiating heat energy, and T2 is a surrounding temperature or enclosure temperature. So this accounts for imbalance between emitted and absorbed radiation, okay. So this accounts means this will have a clear cut idea how much energy is going to be emitted from one object to the surrounding. So this is one of the most important or key concept in the radiation, view factors. So what is mean by view factor? Let's see here. View factor denoted as Fij. View factor, which is denoted as Fij, the fraction of radiation leaving Ai that hits Aj. In simple words, here mentioned as a fraction of radiation leaving AI that hits AJ. And what is here AI and AJ? AI is another surface area and AJ is another surface area. You can take an example again. Okay, so let's say these are the two objects, and if this surface area is going to emit some kind of radiation energy to this surface here, and if they are placed in any position, so this surface area will emit some kind of or some portion of heat energy to this surface area, and that fraction of radiation, that part of radiation or that part of heat energy due to radiation leaving this AI to only this surface AJ is called view factor. So this view factor, how and why it is designed, because in general life you can take an example, while campfiring, then you have observed that, let's say in your village or in your house you are doing campfire, and for if you are sitting just before it or just beside the campfire, only one portion, if let's say here is a campfire in front of you, there is a campfire going on, and only the front side is going to be heated due to the radiation from that campfire. Okay, but your back side is not going to heat. And why it is so? Because only the surface area of your front side is exposed to that radiation. So that's why the view factor is important. How the surface area or how the energy emitted due to that surface area to another surface area of another object is majorly important to analyze the radiation heat energy in actual practices or in engineering applications. So it is purely geometric and depend on the shape, size and orientation. It is purely geometric thing or geometric term of radiation, that is a view factors. So view factor is a purely geometric term which mainly depend on surface area, how it is oriented to another surface area and its size. So whatever the energy is going to emit from this surface area to another surface area is dependent on its size, shape and orientation. Orientation is also important. Likewise, I have given an example of campfire. If you are standing in front of campfire, then only your front side is going to be heated or going to be warm. Your back side is not going to be heated. Why? Because only your front side is only exposed to that radiation. If you put your hand like this in front of campfire, then only your hands will get heated. Your hands back side will not get heated. That is the same relevance of this view factor. Your hands area to that campfire is exposed, and that campfire is delivering the heat in the form of radiation to this surface area only. So we are calculating the fraction of energy which is gained by this surface area or emitted by another surface area of objects. So physical meaning of this view factor, whatever I have just said to you or explained to you, just here illustrated in this figure. So it indicates mutual visibility between these surfaces. Okay, let's take this example. If AI is the surface area of this object, and if this object is emitting some kind of or some part of radiation energy to this surface which is oriented somewhat at certain angle, then whatever the total amount of energy, from that total amount of energy, a part of energy is going to be emitted from this surface to this surface, and this surface will absorb some part of energy. That some part or that fraction we are going to calculate, or we are going to calculate with the help of view factor. And that's why the view factor is the most important thing in this radiation heat transfer, because for spatial applications or engineering application, we have to be very specific or very precise about how the heat transfer takes place and in quantity how much it takes place. So it is governs how much energy is flow from one surface to another surface. So let's take an example of this. If this surface will emit, let's say 10 watt of heat transfer in total, but with this another surface having certain orientation in theta direction, let's say this heat transfer will have 5 watts of potential, then the 5 watt of total heat energy out of 10 watt will going to emit from this surface, and this surface will absorb 5 watt of heat energy. And how these 5 watt are calculated, that is mainly dependent on the view factor. As far as this lecture is concerned, you are not doing a mathematical calculation for view factor, but what is the importance of this view factor and why it is calculated and why it is there in a radiation heat transfer, that you are going to know in this lecture. So importance of geometry, likewise I have said, only the surface area which is exposed to that radiation heat transfer is important to calculate what fraction of heat radiation or what fraction of radiation heat transfer will take place to that surface. We have to calculate that precisely in engineering application that we are going to see in these next slides. So importance of geometry determines magnitude of Fij. Fij means view factor, and what is a view factor? That we have seen the fraction of radiation from Ai, that is surface area of one object, to the Aj, the surface area of another object. So it depends upon orientation, distance and occlusion. So example, small surface facing the large wall. Let's say this is a large or a metal piece, okay, having large surface area, and if this metal piece is emitting some kind of radiation energy, and if this metal rod having surface area less than this, if it is exposed to this, then what kind of or what quantity of energy in the form of heat will going to emit from this larger surface area object to the smaller surface area object is calculated by view factor. So applications of view factor. So we can find many applications in the industry, but to be specific, the furnace design, where we have to calculate how much heat energy is needed for one area in that furnace. So furnace calculation, and the main or major application where we have to precisely calculate how much heat is going to transfer within only that surface area of that component in a spacecraft. So while returning a spacecraft from space to Earth, the spacecraft will experience frictional force, and due to that frictional force, large amount of heat energy is generated, and that heat energy, if it is transferred to the components, internal components of the spacecraft, then there will be chances of failure. So that's why we have to control, or we have to insulate our spacecraft while returning to the Earth's atmosphere. And that's why here a view factor plays an important role, where while returning, the end portion or starting nose portion of that spacecraft will experience high friction, and due to which the nose area of the spacecraft will experience high heat, and for that we have to design special insulating material, and for that the view factor plays an important role. How much energy is going to transfer from that area to internal components is an important thing. So in this spacecraft, the view factor plays an important role to calculate how much heat will be going to transfer to the internal components. So same in electronics and building design, this view factor is important, because view factor is mainly telling us how much radiation energy is going to transfer from one object to another object according to their surface areas. So in furnace design, radiation between hot gases and a refractory wall for specific area we can design, and it affect the wall heating and fuel efficiency. But obviously for burning or for getting heat in the furnace, we have to burn some fuel like coal or any LPG or any gas. So that fuel efficiency will be better when we are focusing to the specific surface area where our components or where we need heating. So in spacecraft thermal control, the radiation is only the heat transfer mode available in the space, because other modes needs medium to transfer, but in space radiation can transfer. So that's why to control this, the view factor used in a radiator and thermal shield design. Here the thermal shield design, just I have given an example. While returning to earth, the thermal shield must be there, otherwise internal components of spacecraft will damage or will get failure. So electronic enclosure, so radioactive heat transfer dominates in lower airflow environment. What is here mean to say? When radiation heat transfer is there, okay, where the low velocity of fluid flow is there, then radiation effect will dominate the other things. What is mean by that? When convection is there in any portion, let's say, again take this example, let's say here the convection heat transfer takes place. How convection heat transfer takes place? This is a hot metal sheet, and if the air is flowing above this, okay, and that air velocity is very small, very less, then because due to this metal plate is heated, and if this air velocity is very less, then the radiation heat transfer will dominate the convection, and that's why the radiation will play an important role than convection. But in another case, if the airflow is having a velocity at higher level or higher side, then the radiation will have minimum effect on this. So it is important for cooling IC chips and components in the electronic devices. In fire safety buildings, so to prediction the radiation from the fire in nearby surfaces, so where the radiation is affecting at what surface, there the fire extinguisher or there the fire safety devices to be used, and that to be calculated by the use of view factor. So it helps or ensure a safe design and material selection, where I want to put a certain material so that surface area will be in the safer position. So passive solar design, the sunlight entering the window and radiating onto the surface. Just I have given last lecture an example of multi-story buildings in metropolitan cities. So there the sunlight enters through the window, and the total building is covered with a glass, thermally coated glass, and whatever the amount of heat is going to enter from that glass into the building is mainly dependent to calculate or to minimize the cooling load. If the cooling load will increase, then we will have no energy efficiency, and to have energy efficiency we have to minimize the cooling load. The cooling load means if any room is there, and if that room is get heated from the radiation from the outside, then that heating must be cooled by air conditioning or HVAC, heating ventilation air conditioning devices, and that's why the cooling load is increased in if we can't control the radiation coming from outside. So the whatever the surface area of the thermally coated glass is there, that is also important. In that, view factor is play important role to calculate that view factor, how we can control the heat energy which is transferring from outside in the radiation form. So it influences the heat gain and in energy efficient buildings. Other key applications like heat exchanger, vacuum insulation, glazing system, cooking ovens, kilns, and spacecraft re-entry shields, just I have explained before. So why the view factor matters? Essentially for accurate radioactive heat transfer modeling. What is mean by that? So again, take this metal plate as an example. As I said earlier, if this metal plate is transferring the heat in the form of radiation energy, let's say 50 watt, then this is the 50 watt is the total energy radiated by this metal plate. But if I put this object, and this object having a small surface area than this, and in some orientation, then what amount of heat energy is going to transfer from this object to this object for only this small surface area? I have to calculate this very precisely in certain engineering applications like spacecraft and furnace and boiler, to minimize or to have a control on heat transfer. Okay, so whatever the specific or whatever the fraction of radiation energy that is going to transfer from one object to another object according to their surface area, here it is essential for accurate measurement of radioactive heat transfer. So directly influencing the energy distribution in enclosures. So how much energy I want to transfer from one surface to another, or how much energy I want to restrict for the transferring the heat in the form of radiation, is mainly dependent on the view factor. So what is the conclusion of today's lecture? The view factor links to the geometry to the radiation heat exchange in the fraction of heat transferring with the radiation, and it is critical for thermal analysis in engineering system. It is a very critical thing. So that's why here in one credit course for introduction to heat transfer, we are not going to see a mathematical form or derivation of view factor, but you are going to see this view factor derivation in your core subject as a heat transfer in third year. But right now we have just go through how the view factor is more relevant in the engineering practices and how it is critical, because to be specific, how much fraction of energy is going to transfer from one surface to another, so we have to calculate it for very special purposes or engineering applications. So thank you very much. So I conclude this lecture here, and you will have 20 MCQ, that is multiple choice question assignment, over this lecture, and you can find that link in the discussion forum box. Please feel free to ask me anything about this lecture or this course in the discussion forum. I will provide you the e-book and e-PDF of this lecture in the discussion forum. Thank you very much.